Hola a todas, hola a todos, hola a todes. Bienvenidos a una nueva edición de VOR OnLive. Como ustedes ya saben, en la navegación aérea VOR es un dispositivo que emite señales que permite que el piloto de la aeronave se mantenga en la ruta correcta. En ese sentido, en Centro, VOR son una serie de diálogos, conversaciones, intervenciones que buscan explorar nuevas rutas creativas y resolver problemas a través de la creatividad. Hoy estamos muy contentos porque vamos a tener justamente un BOR de profunda innovación, un BOR que va a estar tocando en las intersecciones de la creatividad con otras áreas como la ciencia, como el diseño y también con los nuevos tipos y nuevos entendimientos sobre el arte y otras áreas. Entonces va a ser una conversación excepcional en donde vamos, les digo, a tocar esas fronteras, esos lugares en donde el diseño, la creatividad, la biología, lo digital, nos hacen repensar qué entendemos por procesos creativos, por arte, por todas estas disciplinas. Y bueno, estamos muy contentos también por los dos invitados que vamos a tener hoy. Voy a cambiar a inglés para presentarlos porque nuestra conversación será en inglés. So welcome to VOR, where we'll be talking about, these intersections between biology, design, and the digital. I'm sure it's going to be great. I'm going to introduce you to our speakers of the day. First, our very own Diego Trujillo Pisanty. He is a new media artist. He is a professor at Centro, of course, but he's also a biologist and a programmer. So he has a huge background in very interesting fields, very hybrid profile like we're interested in creating at Centro. So welcome, Diego. Thank you for being here. And we're also joined by Raphael Kim. He's a designer, but he's also a researcher in the computer-human interactions. He's interested in biodesign and the relation between technology and biology, and he has a PhD in new media and arts a PhD in media and arts technology. So welcome both. I'm sure that we're going to have a great conversation, and you're going to help us to understand this new ways to understand design, its intersection with technology, with science, with all of this. So thank you for being here and welcome to VOR.
Thank you for having me.
Thank you, Raphael. And thank you, Raph, for being here.
No problem.
I appreciate you giving a bit of your evening, given that you're in the UK, and it's probably dinner time for you by now. As Gonzalo said, we're going to be talking about sort of this strange and quite rich intersection between microbiology and design. I think it'd be good if you would just maybe start by telling us a bit about your work, Raph.
Yeah.
And, the things you did in your PhD, what you're planning on doing, sort of in the near future.
Yeah, so I have a degree in biotechnology, which I graduated from University College London in 2005. And since then, my role with the intersection between biology and design have been kind of morphing over the years. But maybe the most relevant one would be the past 5 years where I've been engaged in PhD research at Queen Mary University. And it's basically looking at the interactions that we have with the microbial world and how that could be mediated through computer interactions. And one of the fields that I was really interested in finding out more was this thing called biotic games. So this is a relatively new genre of hybrid computer games that combine both the microbes, the computers, and the humans together. So he says essentially you have three kind of interactive systems working together. And the whole research really was to find out better ways to design biotic games. But in order to do that, you need to obviously think about how the player experiences would be in these systems. So I've been making a few artifacts to test them out and measure player experiences and kind of really think about how to design these systems properly. So that's my kind of PhD in a nutshell.
Yeah, that's a really good summary, actually. So maybe it's worth getting the presentation up, and maybe you can start talking about specific projects like MoldBrush.
Yeah, sure. So
MoldCraft.
Yeah, so I think maybe the best way to start the conversation about biology and the digital, I think biotic game is a nice kind of genre to start with. So as I explained earlier very briefly, biotic games, unlike the traditional games where you just have two characters between the human and the computer, now you have a three-way system. So I have a classic example of the biotic game here on the right. I'm not sure whether the clip is playing. Yes. So this is probably the most famous biotic game that's available and in the public is Euglena biotic games. So these are an interactive system where you can actually control these tiny organisms called Euglena using LED lights, because they like to swim away from the LED lights. So you can actually control where they swim. And the computer interface essentially is to capture these movements of the cells over time and create these kind of digital interfaces. So this one example is a Pac-Man twist, if you like, of the classic game, and making a Euglena as a part of the computer character. So in terms of the biological digital integration, I think that's probably one of the topics that we'll talk about. I think this really summarizes this concept really well. I see the biology and the digital merging together in a kind of two different ways, which is, firstly, it's the physical integration of the biological world with the computer systems. So you have these tiny organisms residing in a tiny petri dish that are compartmentalized within the computer system. And then you have the virtual integration, where you have the computer software that detects these movements and processes it in real time to create this kind of semi-virtual, semi-analog environment. So that's a really nice way to capture this concept of biology and digital. But there are other ways to express and discuss these concepts as well. And again, another example, probably not the most eloquent example that I have. Yeah, so we talked about the three systems. I think we can skip that. The next slide, maybe. Yeah, so this is the one I created. So I call this a slow biotic game. Essentially what happens is the player watches fungal cells grow on a petri dish, which sounds quite boring, but if you kind of wait around for a long time and see these kind of cells progress over time, it can be quite fascinating. And the whole premise was to have this kind of command and conquer kind of situation where you choose different parts of the petri dish to essentially wager a bet on how much cell that you would actually accumulate over time, and you collect points as a result. It's more of a hybrid long-term strategy game, if you like, and that's been streaming on the famous video game channel Twitch, and we have some really interesting responses and also interesting outcomes, especially visually, kind of spectacular kind of outcomes at the end. So it's been an interesting artifact, if you like, to make and study the player experiences associated with these games. And yeah, so this is another example, again, of the biological digital kind of combining together. So that's a brief introduction to the world of biotic gaming and, you know, the discussion between the hybrid systems.
I think that last part where you're talking about the temporality of life, you know, things have to grow and reproduce, sort of conquer this petri dishes. I think there's something very interesting with when we think about digital, and we think sort of like in terms of immediate reward. So if you go on Instagram, you know, people will like scroll very quickly through 40, 50 posts in 1 minute.
Yeah.
And then I think that's a very interesting sort of change in relationship with Absolutely. The digital itself, where sort of working with the biological enforces a different time frame on the digital.
Yeah.
What responses have you found around that? Do you find people sort of sustain engagement?
Yeah, I mean, firstly, I think one of the inspirations to create Mold Rush game was to really look at what's happening in the mobile phone gaming platforms. I've been hearing a lot about this thing called slow computer gaming movement, where people take a lot of time and effort to engage in a gameplay that's you know, that's either incredibly slow for reactivity, but also very long time to actually finish. So there's a game called Variability. I'm not sure whether you've heard of this game, but it's a mobile phone game where it's essentially a gardening game, and you basically watch these kind of digital flowers and plants to grow on your phone, and it actually grows in real time. So it's incredibly slow process of watching things grow, and that's been one of the very popular games out there, which has been launched, I think, a few years ago. So I think demand-wise and expectation-wise, I think people are changing their expectations in terms of what they want. And slowness, I think, is one of the areas that people are enjoying and also trying to get into. So Mordrush, it was another kind of twist to that. It's a more of a biological twist where, you know, you kind of stand back and say, hey, if these simulations were actually real, and if the simulations were not digitally driven, but biologically driven, what would happen and whether people would enjoy it? And some of the answers that came from the Mordrush study was people did actually enjoy it, and their expectations of what they wanted in terms of spontaneity and reactivity, that was very, very different. But again, you know, it's a very limited sample. It's only one biotic game. There are many more other games to test. And that's one of the things that I'd like to discuss in the future.
And in terms, I think there's something also really interesting when you're talking about the relationship between a virtual plant and then a real sort of mold culture.
Yeah.
I think that for some people there's like this, well, quite valid question about what it means to think about living things as playthings. So you're grabbing a living organism and suddenly it's conceptualized as a plaything. And I think that in terms of design, there are two sides to that. Where, yeah, one is you're designing for the mold to be a plaything, but simultaneously you're doing like a very non-anthropocentric thing, where you have to design for the mold to grow. So how do you sort of balance those two essentially user experiences, where you have the human user and the mold user of your systems?
Yeah, I mean, it's a tricky one, I think. I mean, certainly in HCI, the human-computer interaction field, there is only recently there's been a very strong movement towards post-humanism and non-humanist kind of approaches to design. Let's say, for example, if you take an example of this field called animal-computer interaction, that's a very post-humanist movement where the interaction design is catered towards mainly for the animals and the animal welfare. But for me, studying mold and things that are non-sentient and, you know, they're very simple kind of organisms, it was hard for me to kind of be included in that kind of post-humanist narrative, really. And I think there is another space for people to enjoy and be entertained by simple microorganisms away from kind of post-humanist approaches. But having said that, there are ways to use post-humanist narrative, which is to really think about harnessing these biological qualities that computer systems may not have. So, for example, like we discussed, the very slow mold growth, that's very non-humanist if you think about, because the responses are incredibly slow. If you feed them nutrients, they would actually react, at least visually, very, very slowly. And unpredictability as well. I'm sure we'll talk about the glitches that can happen. The biological system is a very kind of messy and vulnerable system, as you know. And some of the kind of experiences that people can have because of these unpredictability, that's also very post-humanist. So I'd love to leverage this kind of idea of post-humanism in designing experiences rather than for animal welfare and ethics. I hope that answers the question.
Or if it doesn't, it's still interesting, so it doesn't matter if it answers the question or not. I think like a follow-up question on that, and something that you just brought up, is as a designer, when we think about like more traditional industrial design or even digital interaction design, we're used to having materials that are very controllable. So if you buy a plank of wood and you cut it, it's not going to grow or mutate or die or all the things that biological materials do. how do you sort of deal with that unpredictability with your project? Because it does sound like there's potential failure just around the corner every day.
Yeah. So, I mean, if you think about in engineering terms, and also synthetic biology and biodesign field at the moment, it's really towards kind of controlling nature to meet users' demands, I guess, and make things more efficient, sustainable, eco-friendly. But for me, as a game designer, that might not necessarily be the most important thing, to control variability. Obviously, you have to have some control within reason. But as I found out with studies like Mold Rush, unpredictability and variations within the biological systems can be an incredibly fulfilling and very entertaining aspect to have. And like I said about carrying this forward as a design philosophy, it's a nice thing to think about, to have that in your arsenal. I've been going to a few conferences in video gaming, and one of the hot topics is procedural content generation. The way that algorithms can generate these kind of diverse and novel computer artifacts. But if you look at the biological world, that can also be said with the microorganisms and how they react to different environments. So yes, variability can be annoying for engineers and synthetic biologists, but for game design, that can be a good thing. But obviously, there has to be some kind of control.
I'm actually picking up on one of the questions that's there on the comments. Alejandro Hernandez on Facebook is asking if you think that biology and design could change the way we understand what life is or could be. And I think you were sort of like slightly touching on that right now when you were talking about procedural generated graphics, for example, where you have things like cellular automata or genetic algorithms that borrow an understanding of how life works to generate these sort of things. So is that something that you've experienced that with working with microbiology in a design context where the questions are more maybe humanities orientated and maybe not so scientific?
Yeah.
But,
I understand. It's a kind of a tricky question. I mean, when I do my research project, it's not really to do with creating a sustainable world or answering who we are as a person. I think that's more of an artistic kind of endeavor, really. But it's definitely something to think about, because if your work, for example, contains a living thing and contains a biological system, that in itself raises expectations and questions that are geared towards biological systems, for example, safety and bioethics. So definitely you have to think about what you're doing when you're doing things with living things. But I guess it depends what the design calls for. But it's I guess especially if you look at BioArt, then that's what they do, don't they? They use the actual material to send out a message or ask a provocative questions. I think we were talking about this backstage earlier with bioartists. I'm not sure how to answer that question.
Well, I think you already did, to be honest. I think I'd like to pick up on what you're saying about sort of bioart. And I know it's like, I think it's very interesting that you did like a PhD in arts and technology, and then simultaneously you sort of don't like the label artist. Where do you think the difference lies between sort of, and this is, I have an interest in this question because it just came up last week in one of my subjects where we were discussing smart materials and speculation. And there was a discussion, asking like where does it stop being design and start being art? So within the sort of like bio-design and biotic gaming world, where do you see that difference, or what sort of questions are you asking that maybe an artist won't ask, or vice versa?
Yeah, that's a super interesting question. I mean, when I started the PhD research, it was kind of, it was a bit of a struggle, because where does game design fit within art and design? That's the main question, isn't it? And if it becomes biological, then again, where does that fit within bioart and biodesign? And I guess probably the most easiest way to answer it is that could be more of like a third branch with different kind of philosophies and goals, if you like. And gaming has been, receiving very bad rep over the years for, having negative influences socially and culturally. And I think with the biotic gaming, that also brings added complications because you're playing with living things and living entities. All I can say is I think there's definitely a room for a third branch in biotic gaming as a new kind of direction of how to create interactive systems with the living things. This is not a completely new field, I have to say, at the same time. So one of the pioneers of biotic gaming, at least academically, is a person called Ingmar Riedel Cruz. So he's the associate professor at Arizona University. When he was at Stanford University, he started a lab based around biotic gaming and studying how euglena, these microbes, move in space and how designers could actually create systems around it. So it's been going around for just over 10 years. And people have been very, very interested. But in terms of getting more of a mass following, that's not been the case at the moment. So yes, I'd say it's a kind of a third branch, but also a bit of a more complexity added to it because of the life situation.
Yeah. So within that third branch, do you imagine it being more like sort of like entertainment, kind of like the way video games currently work, or?
Yeah, I mean,
something separate from that.
It can be many things. I mean, the gaming itself has different, routes. There's a serious gaming for education and research, but also, like you said, just pure entertainment. I like to borrow a quote from Ingmar's one of his publications. He wrote a line, said that biotic games can be just be fun. It can be designed purely for fun, and I think that's a really nice quote because as much as there are ethical and safety implications that are around it, people shouldn't be afraid to have fun and be entertained by living things and nature. And I take my heart from that. But again,
I think,
yeah.
Sorry, go on.
But there are obviously a huge genre of this kind of serious gaming platform where you can actually study and learn about organisms by gamifying it. And there are plenty of people, for example, Marcus Schmidt and his colleagues, they're working on designing games to educate about antibiotic resistance in microbes.
I think there's something very interesting in what you said just now about things just being fun. And I think that that's something that's sort of lost in education, for example, where engaging with a petri dish growing things can't just be like a very engaging and sort of entertaining and fun experience. And I think sometimes we as designers kind of tend to take things very seriously. And if there is humor or there's entertainment, it must be like very well justified humor or entertainment. So I think that sort of expands beyond hopefully biotic gaming into other parts of design. Or maybe even as professionals, it's fine to do something because you like to do it, and just maybe ignore the market and the client and other sort of design principles for a bit. Speaking of that, I'd like to maybe talk about how you sort of like started to get an interest in this sort of biology plus design sort of mashup that you've been working over the past 10 years, I'd say maybe.
Well, so I started with a biotechnology degree at UCL in London, and I kind of had a brief spell at a pharmaceutical company working as a research intern, working on kind of drug discovery systems. And there was obviously an option of doing a PhD in life sciences. But I guess my real passion was to kind of use biology and the processes to create something that's provocative and kind of engaging and thought-provoking, really. And Don and Raby's kind of work on critical and speculative design was really an interesting option for me to think about the implications of technology rather than the applications. I mean, there's a lot of industry in biotech that is all about applications and what the consumers want. But, Tony and Fiona's take was kind of more into a critical examination of how this technology might play out in society. And I said, look, I've got this biotech degree and I've got a bit of experience in this thing, and I want to kind of see how that's being framed in speculative design. And that's why I kind of was interested in taking an MA in design interactions with you and spend two years of my life. So the kind of this whole kind of spirit of going against the grain of the industry and being critical and provocative, I think that's one of the driving forces of what I do with my work. Biodesign, sustainability, that's all very well and good, and people are making sustainable textiles and biofuels, designing economical biofuels. That's also very good. But things like biotic games, interactive, entertaining things, I think that there's also always a room for questioning the technology. And I think biotic game hits that spot really well, because if you talk about gaming, it's more of a playground, isn't it? You're kind of encompassed in this kind of, I hate to say this kind of magic circle, but it's more of a magic petri dish where things happen and people kind of have this expectations of having fun and being relaxed about it rather than being super consumer focused. That makes sense.
Yeah, I think that's also one of the things that kind of I really like about Dan and Raby's work as designers, where it's sort of an alternative way of thinking of design, not only as in service of the market, but sort of as an agent of questioning. And I think something that really strikes me about your recent work, that maybe wasn't so much there at the RCA, was that you sort of moved beyond speculation, and a lot of the work that we did with Tony and Fiona was about sort of imagining futures, and things didn't really have to work. It wasn't about the story or the critique. And I'm really interested in how you sort of took that route and then took a detour into much more empirical and pragmatic and sort of practice-based ways of working with actual real living material.
That's an interesting question, but it's also a very difficult question, because when speculative designers say they're speculating, they're also making things, aren't they? They create and design physical props made out of real materials. So in a way, I think it's kind of flawed in a way, because when I say I'm doing speculation with biology, you're also drawing a parallel between using biomaterials rather than man-made or artificial non-living materials. So I guess you have to be a little bit careful about when you say you're speculating and not speculating, because props, when they say props, you could always have a biological prop. And I think having hands-on approach and practice-based approach, I think that's very helpful, because you become more familiarized with the technology by getting your hands dirty, and it provides more context and also more experience of what you're talking about in terms of technology. But that's I mean, that's one of the things that when I was studying design interactions, that was one of the things that alienated, I guess, myself from many other designers who weren't using biological materials or processes. So it's a little bit of a weird positioning that you have to take, but also you have to believe what you're doing is good and very productive. I think by setting up, pop-up labs within the RC studio space, actually growing fungi and bacteria in the space, trying out different kind of pigments and colors and injecting things with different nutrients and things how they grow. I guess that can be a form of speculation in itself. I've written an article about this thing called wet speculation. So you're not just prototyping using cardboard or printing materials. You're actually prototyping with fungal cells. And I've written a very short article for a book in 2015 about how people should now be wet speculating rather than dry speculating.
I quite like that term, wet speculation.
Yeah.
It just makes it so, it's kind of like quite provocative in a way. And I think it was nice. I remember like we all had like this very designerly messy desks in that studio space. And then I remember at some point you were in a microscope. It started to look like this very strange mixture between science and design, where you did have like a sketchbook and cardboard prototypes.
Yeah.
But simultaneously you had like a plastic box with things going in it and your microscope.
Yeah.
And I think that's like a nice segue into one of the questions from the comments, where they're asking what are the main skills that one needs to have to do this sort of bio design, or to start maybe playing. I would expand this maybe into both bio design, biotic games, and also asking you how you sort of acquired this sort of very diverse skill set.
Yeah, I mean, I think there's many ways of answering that. I'm not sure who asked the question. I can't see the name, but
Juan Jose Carrizosa.
Okay, that's a very long name. Anyway, I guess the best way to get involved with the biology is to contact one of the well, I mean, there are many ways, but probably the quickest way would be to find a makerspace within your area. So there's a whole thing called DIY biology movement, which has been going on for probably over 15 years now. It kind of started in America and California, and it kind of exploded since. The best website for that is diybio.org. So that's diybio.org. And that's a kind of centralized website where there's a list of all the official biohack spaces in the world. So you can actually search for your country. So Mexico. I think there's just one proper biohack space in Mexico, but I could be wrong. You can have a look. The other way would be to consult your university department. So I'm sure there are Department of Biology or Molecular Biology. You can kind of reach out to them and see how they can collaborate with you. There are many competitions and symposiums, if you like, for this kind of designer meets kind of biology type of situations. I'm sure we'll kind of go through them. I prepared a very short list of appropriate channels to contact to get into biology. And second part of the question, I think, was kind of my take on things is, I mean, I do have a biological experience, so I guess I have a slightly head start in terms of what processes and reagents and protocols that I would need to do a certain project. But that doesn't mean that I know everything in this field, and I'm still learning, actually, because I'm sure Diego, with technology, it's always changing and always evolving. CRISPR-Cas, for example, that's not been in mainstream use in the last 15 years ago, and now I need to learn these kind of things, because when I was a scientist at a pharmaceutical company, we didn't use CRISPR systems. We used a very kind of traditional cloning systems that they were using back then. So always learning, always reading, and looking out for publications and reading up the news. I think that's another way to do it. But just be always on top of what's happening in technology. I think, Diego, you could also give us a bit of an insight into how you could or you might want to engage in biodesign. Maybe you could give us some clues.
Yeah, I think, I mean, I come from a similar background as you, but I was heading the other way. So I came from biology and sort of started to want to do more digital work. And that came from working in artificial life, like trying to program things to behave like real life. And for me, it was a bit the opposite. The knowledge that I had to gain was sort of the whole digital part. I didn't have like the bio side covered. And I sort of lost interest in that with time. So my current work, for those of you who don't know it, is much more digital and social, less biological. But I think that when you mentioned biohacking, and we'll go back to that in a second.
Yeah.
I think that the common ground for both of us is that there's the self-learning thing, where, you know, if you spend 1 hour Googling how to do anything,
yeah,
you find so much information, it just becomes so hard to parse all that content and to engage with it. And I think that's something like we're joining a hackerspace, for example, for digital things or biological things. Sort of gives you like a nice community to bounce ideas around and get your questions answered by someone who's been there a bit longer. I think there's also something very interesting in not having to go to the expert. So you mentioned, we'll go back to that again, sort of contacting a university's microbiology department and trying to collaborate with them.
But I think just to add on to that, Diego, I think the beauty of the biohack space is people have non-kind of academic agenda necessarily, or non-commercial agenda. When I was a member of the London biohack space in the UK, a few people are talking about studying, you know, diseases or antibiotic discovery that pharma companies would not dare to touch because it's very unprofitable. But for some reason, whether it's a personal kind of motivation or someone that's close to them, they have this kind of motivation or a drive that's not usually found in academia or corporations. So if you have ambitions as such, I think biohack spaces could be the right one for you. But it also depends on the context and your projects.
Actually, I think it might be worth sort of defining what biohacking is, because I mean, speaking of digital and biological sort of coming together, the word hacking has like certain connotations within cybersecurity and sort of like this whole hacktivism thing. So what does biohacking entail? I mean, it's obviously not stealing bacteria's bank accounts.
So I think, well, if you Google biohacking, it can come up with many different results. I think at the moment, the kind of public knowledge of what biohacking is and how you define it, there's threefolds. I think the first one is this idea of DIY biology. So like we discussed, it's probably the most common, most well-known form of biohacking. So this is all about open source materials of biotech, open protocols, open data. And also there's a lot of guys working with digital technology of creating computer systems that can work with biology in a very kind of low cost area. Outside of that, there is just to kind of get it out there. Other forms of biohacking include body modification. So you have this thing called grinders, where you have implants and chips within your body to do kind of like semi-cool things like opening elevator, like doors, automatic doors. So that's another form of biohacking if you Google it. A third one is I think called nutrigenomics. So that's probably the more later version of what biohacking is in this thing, is hacking your body with food. So you have like special formulations to improve your health, for example. I don't know that field very much, but it's one of the defined definitions that can come up with biohacking. So just have to watch out for what they actually stands for. But the most general term is DIY biology, do it yourself. I hope that.
And sort of going back to those sort of first experiments in biology and design that you were doing in 2010, 2011. I mean, I think from my perspective, there was a point where you sort of just went on with it and kind of like became quite fearless of ordering a bag of petri dishes online, ordering a growth medium, or just I don't know, putting your lunch leftovers in a box and looking at that grow. I mean, was it sort of like that from your perspective, or is there sort of like a more methodological starting point? Because I think some of the questions here are, it's quite daunting to get started with something you don't know. It's not something that, we don't have a biodesign module in any of our degrees. So, I mean, what would be your sort of advice, sort of like get the ball rolling with these interests?
Yeah, that's a terrific question. I mean, I guess you just have to have some idea, at least, even if it's a rough idea of what you want to get out of your project. So, I mean, I probably can't answer that for everyone, because everyone has different kind of expectations and needs for their designs. But one thing I can actually say, which might be helpful, is don't over assume things when you're working with biology or doing biological projects, because the awareness and the education of the audience might be incredibly different from what your knowledge is, or what your collaborators' knowledge is. So take one step at a time and do incredibly basic things, even if it looks very basic to you. So, for example, when I was working with bacteria, I wanted to kind of create this really weird and fantastic kind of object made out of dried bacteria. And I think, Diego, you were kind of involved in this at some stages. We got one of the Imperial College scientists to centrifuge down these E. coli cells so that I could take it and kind of solidify it into dry powder. And the idea was to kind of coat this bacteria onto these kind of objects, 3D objects, to create this notion of living objects. But I think the most important lesson I learned was to communicate what the process is rather than the actual object itself, and why I was doing certain protocols like spinning things down and drying things. So yeah, that's one thing I could say, is just to be really aware of what each step and the process means to the audience, and whether you need to communicate that. Because, if you just show some projects with objects that are kind of whitish color and, very inanimate, that doesn't bode well in terms of the communication. So yeah, just holding yourself back and not assuming things, but also communicating your processes and documenting it. I think that's one solid strategy that you could have in your projects. And by the way, just for the record, it wasn't an Imperial College scientist at Imperial. It was at BioHackSpace. He used to work for Imperial College. Yeah.
Right. So that collaboration with sort of like an established institution came from that sort of like informal gathering.
Yeah.
Cool. And when you mention process, I think that something that sometimes we struggle with students is that when you have very experimental projects, the process is a result. So I think that things like mold brush, for example, they're just an ongoing process, and there's no final thing. I mean, I don't know if there's a question, or if it's just more of like an observation, but
yeah,
I think that's sort of like very hard to communicate sometimes, even within academic work, like the one you're doing. So, I mean, is that something that you see your work as doing, presenting process as product, or do you think that the process is sort of like when you're sketching and building these things, and that the machine itself is like
I haven't really thought about how to communicate the process of biology, I guess. But again, one thing I can say is, because you label this product or an object a game, a video game, that creates a context. So that creates a framework for you to discuss whatever aspect that might interest you. So, for example, I was interested in this idea of novelty generation in gaming, and by labeling this kind of fungal growth in terms of novelty generation, that was a really nice way to kind of segue to kind of discuss how novelty could be generated through biological systems rather than computer systems. Yeah, I'm not sure whether that answers the question, because it's, yeah, I guess partly it's down to how you communicate and how you brand yourself as a researcher / designer. I don't know if that, how you would do it yourself, Diego. I mean, it doesn't have to be biological processes, but if you're working with kind of technology or new media, how would you go about doing that?
Yeah, actually, I think with students, sometimes we, for example, put a lot of weight on documentation. And sometimes if you're mixing sort of like gooey fluids, growing slime, and then having like a good series of photographs that sort of presents that process can in itself become an outcome of the work. I think, for example, Daisy Ginsberg's Chromai sort of fits within that space where there's fairly good documentation of the work being done in the lab, followed by sort of design props that are not made from biological material.
Yeah.
That sort of support how that process turns into design work.
Yeah.
So also, I think.
Yeah, sorry, go on.
What I find interesting in this biotic gaming thing is that process is sort of like self-documented by the game itself. And sort of like looking at that process unfold becomes the experience somehow.
Yeah. Yeah. Yeah, because it's an interesting concept, because they're making the work for you, aren't they? In a way, you don't have to constantly be in a studio or a workshop to keep creating your documentation, if you like. That's a super interesting concept. Yeah, but I haven't really considered that as part of a biologically automated system. But for sure, that's really important. And just to add on to that, in terms of how you design with these kind of things, you gotta obviously remember that things need to, if you want to design an interactive system with biological materials, you have to have a long-lasting system. One of the authors that I always cite is Lucas Gerber. So he published a list of design guidelines for creating biological interactive systems. And one of the things he says that you have to have a robust system. So if you have something that's growing over a long time, that system has to sustain itself without much intervention and cost to actually get your project finished. But there are other kind of tips and nuances that you could apply to biodesign, which I will kind of link towards the end of the talk. One more thing on that subject, Diego, I think documentation is super important, especially for projects like this, because you have to have some kind of grounding and believability of what you want to communicate. So speculative design is all very well and good, but if you don't have the right documentation or right grounding, your story or your narrative would not be very profound or active. It doesn't have to be speculative design. I mean, it can be party games or other types of designs, of course. But yeah, grounding and believability and plausibility.
Yeah, and you mentioned like this thing about robustness in relation to interactive systems. So maybe thinking about sort of short-term futures for biotic gaming. There's a question from Rodrigo da Silva here asking, what do you think AI could do on this field? So if you had like better computer vision algorithms, or even in terms of automating robust growth systems, have you thought about sort of integrating machine learning and AI into biotic games in a way?
Short answer is no. But it's an interesting concept. Yeah, for sure. Yeah, how would one do that? One interesting thing I can remember on machine learning is there was a paper published recently I think it was a guy called Tavella, his surname's Tavella. So he basically proposed a system where machine learning can be used to detect, I'm botching this totally, but I will refer the publication later on in the talk, to create kind of piracy-proof DNA data storage. So there's a whole talk about how DNA can be a storage material for digital data to kind of prevent the need for data storage in the digital format. But this guy was using machine learning to create a very efficient system to detect like malwares in the DNA data storage or something along those lines. So machine learning and biology, there's definitely a room for it. And there are publications coming out. So I will definitely link that paper after the talk. But short answer, no. But yeah, long-term work, yes, for sure. I mean, there's definitely a room for research and creation.
And I think because, specifically neural networks and artificial intelligence are quite technical programming topics where you have to have certain skills in linear algebra and calculus to sort of understand the underlying theory before you sit down and code things. Yeah. I think that's where collaboration becomes very important in mixing biological and digital. I think it's essential to have at that scale, like very good coders focusing on the code, and so like very good microbiologists focusing on the sort of chemical and biological side of things. As we're already looking at questions, there's another interesting question from Juan Cantu asking, what is the role of aesthetics in your work as a biodesigner? Or to what extent are you in control of the way things look? Or is it something that you don't worry about and just know that whatever life does, it will be interesting?
Yeah. Well, I mean, if you're talking about just purely visual aesthetics, going back to Lucas Gerber's design recommendations, one of the things that he cites is you need to have a hardware and software solutions to counter variability within biology. So he talks about how, like the LED lights has to be like continuous rather than analogous. So the variability of the cell's movement can depend on the intensity of the light. And he was very kind of adamant about how softwares and hardware could be designed around that. One philosophy I like to take on it, I mean, I do understand his kind of point of view, but I think embracing aesthetics and variability is a good feature potentially, especially if you're working with fungi and aesthetics. So yeah, that's a two-part answer. One, yes, of course, we should embrace biological aesthetics because it's cool. It's incredibly distinct. I know that computer simulations have come a long way and they can mimic biological things very well, but still nature is nature and it's very hard to simulate or mimic in that way. So yes, we should embrace aesthetics and visual things like that. But also it depends on what the functionality is for your design.
And maybe we're starting to run out of time, sort of like come to a close. Finally, I would ask you, so you've been working mostly as an academic for the last, a good number of years now. So how do you see this sort of moving beyond academic design into maybe more mainstream design, or not necessarily working with biological material, but maybe also some of the ideas and processes? So things like, for example, embracing variability. So yeah, just in general, like where do you see sort of your work kind of?
Yeah. I mean, I'd love to. I mean, my kind of short-term plan is to stay in academia to carry on with my research, but kind of branch out from not necessarily gaming or game design, but just interaction design in general. I mean, the artifacts I created, like Mold Rush and Moldcraft, for example, I mean, obviously there are marketable kind of potential out there, But I think these were created just purely for research purposes of finding out the player expectations and experiences of these systems. I mean, I don't really have any concrete kind of dreams or kind of, plans to actually commercialize it per se, but there's definitely a room for that. And in my Radio Cruises lab, for example, they kind of presented this kind of graph of how consumer electronics were kind of surging over the 1980s, and the whole computer game as we know it has been kind of exploding onto the scene. And he was kind of comparing that to biotic gaming, where it's kind of catching up. And I think he was predicting this kind of decade to be the one where the marketable biotic gaming would actually come onto the market. Obviously, the jury is still out there, and people will see what happens. But yes, there's definitely a room for commercialization. But on a personal note, I like to remain in academia and kind of do further research.
Yeah, and maybe finally, and also picking up on a question I missed earlier, how do you sort of deal with this? So I think when we talk about biology and technology, things like Neuralink and cyborgs and stuff like that come up.
Yeah.
So in your work, when you're creating systems that mix biology and technology,
yeah,
how do you sort of move beyond that sort of healthcare, cyberpunk, maybe also transhuman perspective? I mean, how does working with bacteria and fungi?
It's a tricky area because I think it's all about perception, because public perception of biological intervention, if you like, has a very kind of deep connotations of, like you mentioned, the transhuman, the cyborgs and Neuralinks, which isn't necessarily a bad thing. But I think there needs to be more nuances when we talk about biological things. It doesn't have to be gory or incredibly kind of absurd looking. So what I tend to do is kind of compartmentalize it by labeling it as, let's say, a computer game. So it has a framework and kind of well-established boundaries of what people expect. So in that way, to frame it in a kind of game design sense, that helps. But also it's for us to really communicate the nuances within microbiology. It doesn't have to be, COVID-19, or it doesn't have to be Ebola when we talk about bacteria or, salmonella, for example. It doesn't have to be those kind of things. But as a designer, you always have to be an excellent kind of PR person or a communicator to really bring out these nuances. It's a difficult one because, I don't think there's a right formula to actually communicate these nuances, but I think you can just keep trying.
And I think sometimes you can use them to your advantage, right? Like if people are interested in sort of like cyborgs and sort of human-computer interfaces.
Yeah.
I mean, say brain-computer interfaces. I think that can be like a good starting point to say, actually, it doesn't all have to be sort of super ethically challenging or, that level of technicality where, we don't even understand the brain. We're already like inserting wires into it. So I think it can be like one of those things that you pick up and then sort of like divert it to sort of maybe more poetic or.
That is such a good point. I mean, so using biology as a kind of hook to really kind of draw the attention of the audience, I think that's a super smart idea to do it. And once you hook that person, you can actually create these kind of nuances that people would appreciate. So that's super, super nice advice and a really good point.
All right, so maybe just to finish, I think we'd ask you to sort of prepare some sort of references or recommendations so that people who are watching can look at maybe other people's work, books, films, anything like that.
We've talked about a bunch of stuff. I mean, one of the slides actually mentions some of the resources, but I think the best way, Yeah, so DIY.org, we mentioned about biohacking and how to get into the spaces within different countries. Biotic games, so there's a massive database curated by a guy called Wim van Eck. He's a Dutch designer and researcher. So you can actually find historical examples of biotic games that you could look at. And obviously Ingmar Riedel Cruises Lab in Arizona. So they have a really extensive publications on biotic game design. And below are just two of the papers that I've talked about or mentioned very briefly. I think there are at least 5 or 6 other elements that we haven't listed here, but were in the conversation. But I'll send that to either yourself, Diego, or to Gonzalo. Maybe you can share extra references. I mean, that is just too brief for the entirety of the conversation. But yeah, I'll definitely send those through. And lastly, I think the next slide, if you have any more kind of personal, if you want to contact me personally, there are my contact details. I'm just kind of finishing up on my new website, so you can actually visit on past projects as well if you're interested in finding that out. So yeah, that's pretty much it.
All right, well, thanks a lot again, Raf, for taking the time. Thanks to everyone who joined on the different streaming platforms. And obviously thanks to Gonzalo and everyone else at VOR for organizing and
I was just gonna come in to say thank you both at the name, thank you for joining us. Thank you for this incredible conversation. You're right, Raf and Diego gave a lot of references. So if you're interested in a follow-up, please, if you didn't register to the event, please leave your contact information, your email in any of the platforms, and we can send you a follow-up. We'll do a summary. We'll let you know all the contact details of Raf and Diego, and as well all the references that were mentioned. So please give us your contact details. Of course, you should check out oral technology programs at Centro so you can do this kind of amazing hybrid transmedia work that Diego and Rafa are doing. So thank you very much. And I hope that Raf can come to Mexico whenever it's possible, so you can probably give a workshop and talk more in person about all the great stuff you're doing. So that would be great. And Diego, please, he's our teacher, but he's also a great artist, so also check out his work, which is also great. And well, thank you for joining us at VOR. If anyone has any questions, please feel free to contact us at Centro, and we'll do follow-ups on this talk. So thank you, Raf. Thank you, Diego. And I hope that we can meet soon in person too. But it's great to have conversations. London and Mexico, that's always great, at least.
Yeah. It's been a pleasure.
Well, we're looking forward to having you over at someday.
Great.
Raf.
Thank you.
Gracias a todos. Por favor, síganos en redes y sigan nuestro follow-up. Por favor, déjenos sus datos. Si se registraron, les llegará a su correo. Y muchas gracias a todos por estar con nosotros en nuestro VOR. Tendremos más a lo largo de noviembre y diciembre. Entonces, por favor, manténganse al tanto de nuestra agenda. Muchas gracias and thank you both again.
Thank you, Gonzalo.